The wild world does not promise fairness. Each day begins with simple needs: find food, hold territory, protect the young, survive one more night. Strength can open a path, but it cannot protect everything. Speed can carry an animal away from danger until the body is forced to stop. Numbers can create safety, but once the formation breaks, one individual can be left behind. Across grasslands, forests, and dark waters, every living thing carries its own advantage and its own limit. The outcome can depend on a short distance, a slower movement, or a moment that comes too late. The stories ahead are not only about winners and losers, they reveal how life continues, even when every advantage is tested. The African savanna has no rules and no intervention. Here, physical strength determines which individuals persist. Each time the largest animals appear, natural order is immediately tested. This opens the most severe confrontations on this land, where blood, sweat, and survival instincts collide directly. The dry season spreads across the savanna. Green grass disappears. Temperature rises and water becomes scarce. Pressure weighs on all organisms and forces constant vigilance. A single moment of contact can trigger a conflict with no retreat. African Cape buffalo are among the most dangerous hoofed animals on the continent. The body is massive and an adult male can weigh approximately 1,980 pounds. Large mass combined with fast reflexes and immediate threat response makes any collision with this species extremely risky. In many ecosystems, buffalo are classified within the Big Five, not because they are rare, but because of the level of injury they can inflict when pressured. When conflict occurs between two adult males, it is not a random encounter. It is a full-force confrontation where all muscle mass of the neck, shoulders, and head is engaged. Both individuals charge at high speed and generate extreme impact force. Pressure focused on the head and neck is sufficient to transmit shock through the entire body. These contests usually serve to establish hierarchy or access to females within the herd. The key factor that determines impact tolerance in male buffalo is the boss structure on the forehead. This is the horn base that thickens with age and later fuses across the forehead into a solid bone mass. This structure does not exist in juveniles. Bone density in this region is extremely high and absorbs and disperses force. During frontal collisions, individuals with a continuous smooth boss are typically males that have survived multiple confrontations. Buffalo horns do not serve only as protection. They are actively used for attack. During a charge, the head lowers and horns point forward, hooking into the body or neck of the opponent and lifting forcefully. This tactic causes even large predators to carefully evaluate risk before approaching a healthy adult. Selective pressure operates continuously. Bone structure, strength, and damage tolerance determine which individuals pass on genetic material. A minor error in a single collision can alter survival outcome. Such confrontations are never isolated events. Along slow-moving rivers and extensive wetlands of Africa, hippopotamuses control space in a very different manner.
Most of the time, the massive body remains submerged with only eyes, ears, and nostrils exposed. The surface appears calm and can be misleading. In reality, this is one of the most dangerous mammals on the continent, with exceptionally high aggression when territory is violated. A hippopotamus can open its jaws extremely wide, approaching a straight line. Large jaw structure and a short but extremely strong neck generate tremendous bite force at close range. Most body mass is distributed across shoulders, neck and head, which stabilizes attacks on land and in water. Movement is not fast over long distance, but is explosive and precise in confined space. Territorial behavior in hippopotamuses is maintained continuously and does not follow seasonal patterns. This pressure contributes to limiting population density in wetlands and narrow river sections. Hippopotamus habitat therefore remains a high-risk zone for any organism that enters. During each wet and dry cycle, African savannas enter a period of major transition. Millions of hoofed animals move in the same direction, following fresh grass and water sources. This flow includes approximately 1.5 million blue wildebeest, hundreds of thousands of zebras, and large numbers of gazelles. The scale compresses space, restricts visibility, and amplifies every mistake. Within this movement, wildebeest and zebras often appear together. This occurs not due to shared social behavior, but because of complementary biological traits. Wildebeest possess well-developed hearing and olfaction. They detect unfamiliar scents, abnormal sounds, and ground vibrations from long distance. These signals allow early response to predator approach or environmental change. However, a short neck structure and grass obstruction limit direct visual observation when moving in dense formation. Zebras provide a different layer of surveillance. Tall bodies, heads held above grass level, and eye structure allow wide area scanning. A broad field of view enables detection of movement from multiple directions simultaneously. Combined, the two species form a distributed warning system. Sound, scent, and motion are processed in parallel, reducing the chance of surprise approach. However, herd structure does not operate on mutual protection. Each individual reacts based on direct survival benefit. When a predator has focused on a target, the remainder of the herd tends to separate, increase distance, and reduce personal risk. Returning to assist does not provide evolutionary advantage under constant pressure. This apparent indifference is a product of natural selection rather than behavioral error. Zebras traveling thousands of miles face heavy pressure from food shortage, herd collisions, and constant threat. Common responses include strong kicking and maintaining personal space. Within dense movement, any obstruction that disrupts travel rhythm can be attacked, including juveniles of other species. Despite strength and strong senses, zebras remain primary prey. When light decreases, predator detection weakens. Individuals that separate from the herd, fall out of rhythm or move alone, become easier targets. During the Great Migration position within the herd and ability to maintain movement rhythm directly determines survival probability. Even when buffalo herds maintain position against predators, the hierarchy of power on the savanna does not end there. At the highest level stands the African elephant. A single individual is sufficient to exert pressure across the surrounding space. Elephant presence alters the behavior of many other species without the need for formation or collective response. The ground vibrates lightly with each step. A safety distance is established immediately. The African elephant is the largest land animal alive today. An adult can weigh up to about 13,000 pounds and stand over 13 feet at the shoulder. This mass creates an absolute advantage in any confrontation. No predator chooses to approach a healthy elephant directly. The risk of injury is immediate and uncontrollable. Elephant body structure is optimized for power. The trunk is the most prominent feature. With more than 40,000 independent muscle bundles, the trunk provides high precision for fine tasks and strong pulling force in conflict. It can strike, push, lift, or hold objects at a safe distance. In many situations, trunk movement alone is enough to force other species to retreat. Elephant feet are another under-recognized tool. Large contact surface combined with body weight generates extreme pressure when placed on the ground. A precisely placed step can destroy vegetation, deform soil, and cause severe injury to any organism within the impact zone. This power does not require speed, only position. A common Savanna anecdote involves so-called marula fruit intoxication in elephants. Surface observation shows some individuals moving unsteadily after consuming marula fruit. However, biological analysis indicates that alcohol intoxication is very unlikely. To affect the nervous system of a multi-ton animal, the required quantity of fermented fruit far exceeds natural conditions. Elephant digestion also operates, rapidly limiting alcohol absorption. Another hypothesis involves insects living in marula bark. Larvae of certain species contain compounds with mild neurological effect. When elephants consume bark, the combined intake may cause temporary balance disruption. Additionally, stimulation from nutrient-rich food sources can lead to unpredictable behavior. Regardless of cause, an uncontrolled elephant in confined space always represents high risk. On the savannah, safety limits around elephants are clearly defined and rarely challenged. Rhinoceroses exist as a biological paradox. The body is massive, with weight that can exceed 3,080 pounds. The skin is several inches thick with dense fibrous structure that is difficult to penetrate. A horn on the nose grows continuously and is hard enough to break most obstacles along the movement path. This strength is paired with a serious limitation, which is very poor eyesight. Rhinoceroses do not see objects clearly at long distance. Beyond about 98 feet, images become blurred shapes without defined form. Details cannot be distinguished. Intent cannot be identified. In open environments such as savannas, this turns any unfamiliar signal into a potential threat. Rhinoceros survival reflexes are built around this limitation. When unfamiliar scent appears or abnormal sound is detected, the nervous system shifts into high alert. There is no prolonged observation phase. There is no multi-step assessment. The response is nearly immediate. The chosen approach direction is straight ahead. Speed increases rapidly over a short distance. The objective is to remove the source of disturbance before it approaches closer. As a result, collisions with non-living objects are not rare. Dry tree stumps, dense bushes, large rocks, and even stationary vehicles can be interpreted as threats if they enter the sensory zone. For rhinoceroses, there is no concept of correct or incorrect response. There are only two states, which are safe or must be removed. Stress reaches its highest level during the breeding season. Adult males expand their activity range and increase contact with other individuals. pressure on females rises noticeably. A commonly recorded behavior is the expulsion of older calves from the area near the mother. This interrupts the care process and accelerates the return of the reproductive cycle. For females, this period requires continuous defensive response to protect dependent offspring. The most severe conflicts occur when two adult males dispute territory. Both approach in straight lines with heads lowered and horns pointed forward. Rhinoceros horns are made of keratin, which is the same biological material as nails and hair, but densely compressed. At high-speed impact, the horn can penetrate thick skin and cause deep injury. These fights do not end quickly. They can last for hours, with repeated separation followed by renewed charges. Rhinoceroses are designed for pure strength. However, limited perception and high territorial behavior place them in a state of constant conflict. On the Savanna, every charge by a rhinoceros carries risk for other organisms and for the species itself. The greatest advantage of African buffalo does not lie in individual animals, but in herd structure. When gathered in sufficient numbers, a buffalo herd forms a tight, coordinated moving mass that is extremely difficult to approach. An adult male often weighs close to 2,000 pounds and possesses a dense skeleton, a powerful neck, and outward curving horns. The dense formation shields all approach directions. Under these conditions, even top predators rarely choose a direct attack. The herd response occurs very quickly. When the boundary is breached, individuals on the outer edge immediately turn toward the threat. Those in the center maintain stable positions. The entire herd shifts state within seconds from stationary to active movement, expanding control of the surrounding space. The pressure does not come from a single animal, but from combined mass movement and synchronization. However, this structure is only effective when it remains intact. An individual separated from the herd faces a much higher level of risk. An adult buffalo may exceed the body mass of a lioness, but this does not guarantee complete safety. Predators do not rely on direct force confrontation. They focus on exhausting, disrupting, and sustaining pressure on the isolated target. Such hunts often involve coordination among multiple lionesses. They rotate approaches, forcing the opponent to move continuously. The objective is not immediate takedown, but reduction of response capacity. These situations occur repeatedly across the savanna, creating continuous interaction cycles between predation, defense, and re-establishment of spatial order. Not every dangerous predator in Africa requires speed, massive size, or conspicuous movement. In many ecosystems, the most effective threat comes from organisms that produce almost no signals. There is no sound. There is no warning. There is no prolonged pursuit. A single moment of close approach is enough for the event to end. The African rock python is a typical representative of this hunting style. It is the largest legless snake on the continent and operates primarily through concealment and patience. The long, heavy and flexible body allows absolute advantage in confined space, where quick reflex matters more than speed. The prey range of the African rock python is very broad. Medium-sized hoofed mammals, primates, wild pigs and reptiles living near water are included. After the prey becomes immobile, the python begins swallowing from the head. An expandable jaw structure allows enclosure of bodies much larger than head diameter. Within African ecosystems, the African rock python does not require direct competition with larger predators. Its strategy relies on surprise muscular endurance and control of prey within extremely short range. For the African rock python, silence is not a resting state. Silence is the optimal condition for ending a hunt. The survival stage in Africa does not belong only to massive bodies. At the edge of this system exists a much smaller species. That is known for an unusually high level of risk-taking behavior. The honey badger. It is a medium-sized carnivorous mammal recorded in the Guinness World Records for confronting opponents that exceed it in size and biological weaponry. The honey badger has a unique body structure. The skin layer is about 0.24 inches thick and is not tightly attached to the muscle beneath. The diet of this species includes many dangerous animals. Snakes make up about 1/4 of the diet. The honey badger has strong venom tolerance, which allows continued movement and counterattack after being bitten. However, this advantage is only effective against opponents that rely on venom. When facing a predator that does not use chemical toxins, the entire strategy must change. The African rock python is one such opponent. There is no venom. There is no need for repeated biting. The attack method relies entirely on constriction. When the body coils tighten, venom resistance has no value. On the savanna, willingness to engage produces many victories. When facing pure mechanical strength at the highest level, persistence no longer determines the result. Among these species, one bird holds a central role and can alter the order of an entire feeding event. The lappet-faced vulture is such an individual. Large body size, assertive behavior, and direct access to food sources that most species cannot reach define this role. This bird has a wingspan near 10 feet, which places it among the largest in Africa. This size allows rapid access to large carcasses and maintenance of a dominant position. When it arrives, other species usually withdraw. This is not due to numbers, but due to body structure and biological tools. The thick, curved, sharp beak can penetrate the extremely thick skin of elephants, buffalo, or rhinoceros. This is material that many other scavengers cannot process. In natural decomposition, nutrients are often locked inside thick skin and dense tissue. Without an initial opener, much biomass would not be accessed in time. The lappet-faced vulture performs this exact role. It creates an entry point. After the protective layer is breached, smaller vulture species can access the soft tissue inside. This activates the entire scavenger system. However, this order is not equal. The lappet-faced vulture holds the central position, selects the most energy-rich portions, and feeds first and in larger amounts. Only afterward do other species feed. This relationship is bidirectional. Smaller species require the penetration ability of the larger species. The larger species benefits from group gathering that improves carcass detection over wide areas. The name lappet-faced comes from the folded bare skin structure around the head and neck. When activity increases or competition occurs, blood flow concentrates in this region. Skin color shifts from pale to deep red. Recent physiological studies show this helps release heat during high-intensity activity under strong sunlight. At the same time, the strong color signal functions as a visual warning and reduces the need for direct conflict. The lappet-faced vulture is not only a scavenger, it is a decisive link that controls the speed and efficiency of energy redistribution. When this species disappears, large carcasses persist, longer decomposition slows, and many other species are affected. Its presence keeps the biological cycle operating at the correct pace. This large animal does not rely on canine teeth and does not depend on forelimb strength. The primary advantage comes from vertical reach. The African giraffe reaches nearly 20 feet in height and occupies a spatial layer that most other animals cannot access. Height is only the visible feature. Behind it is a biological system designed to counter gravity itself. To move blood from the heart to a brain positioned more than 6 feet higher, the giraffe body functions as a high-pressure pump system. The heart weighs about 24 pounds, with thick muscular walls and strong contractions. Blood pressure is about twice that of humans, but is tightly regulated to prevent vessel rupture. One way, valves in the neck veins prevent blood from rushing downward when the head is lowered. The brain remains protected from pressure shock even as posture changes repeatedly. In the giraffe world, height does more than support observation and feeding. It determines reproductive order. The long neck is the result of prolonged evolutionary pressure, where body structure governs both survival and competition. The greatest threat to large animals does not come from teeth, claws, or natural competition. It comes from humans. When large species persist, the entire ecosystem retains structure and functional rhythm. If they disappear, nature becomes depleted, weakened, and unable to self-regulate. Decisions and actions occurring at this moment will determine whether these species continue to live in the wild or remain only as records in scientific archives. At the center of the African savanna, the environment remains under constant strain. Heat rises from the ground, causing the air to shimmer above dry grasslands that stretch to the horizon. Dust stays suspended, and the smell of hot soil and withered grass fills the space. Living conditions change continuously, with no factor remaining stable for long periods. Here, the existence of animal species is never guaranteed. Each day introduces new demands for energy, water, and temporary shelter. Biological rhythms operate at high intensity. A minor deviation can interrupt the survival chain. The savanna is vast but difficult to access. Food resources are unevenly distributed. Water sources shift with the seasons. Species are forced to expand their movement range and continuously adjust behavior to adapt to environmental pressure. There is no extended period of rest. Conflict occurs frequently. Territories overlap, movement routes intersect. Species compete directly for grass resources, carcasses, and secure locations. Each encounter consumes energy and forces precise evaluation by the individual. Under intense sunlight, this sequence of actions repeats day after day. Life continues not because conditions are favorable, but because of endurance, adaptation, and timely response within a constantly changing environment. Within the continuous chain of conflict on the savanna, some encounters leave clear physical outcomes. One of these involves confrontations between lions and African warthogs. These events are not frequent, but when they occur, survival pressure on both species rises sharply. Lions approach under full control. Movement remains low, slow, and continuous. The body blends into tall grass, minimizing detection. Distance closes step by step. No movement is wasted. Each approach aims to gain advantage in the decisive moment. Warthogs do not remain stationary in danger zones. Their bodies are compact, but reaction speed is high. The head stays raised, while ears and snout continuously scan for signals. When pressure is detected, direction changes immediately. Running paths are unpredictable. Short and abrupt turns force the approaching predator to adjust constantly. The primary defense of the warthog lies in its curved tusks, sharp enough to cause severe injury at close range. African wild dogs belong to the group of predators with the highest hunting efficiency on the savanna. Their prey takedown rate is extremely high compared to the general average. This result does not come from individual strength or body size, but from a hunting method that is tightly organized and precisely repeated across many generations. Unlike solitary predators, African wild dogs always move as a pack. Formation is maintained even during long-distance travel. Each individual holds a specific position and performs a defined function during the chase. When a target is detected, the pack spreads rapidly, creating pressure from multiple directions at the same time. The hunt usually begins with speed. African wild dogs do not rely on prolonged ambush. They force prey to move continuously, cut off escape routes, and push the target toward exhaustion. Distance is maintained at an optimal level, close enough to apply pressure and far enough to avoid counterattack. This process can be extended, but it rarely exceeds the prey endurance limit. When the prey weakens, the pack tightens the encirclement. There is no hesitation. There are no pauses. When the prey collapses, consumption occurs very quickly. The carcass does not remain on the ground for long. Multiple individuals feed simultaneously, with each portion processed immediately upon access. This limits the arrival of scavenger species and reduces the risk of losing newly obtained energy. For species such as warthogs, the outcome can occur within a short time. Individual defensive ability is insufficient against continuous collective pressure. However, not every hunt is successful. African wild dogs pay a high energy cost for each pursuit, and failure still occurs. When conditions are unfavorable, African wild dogs do not maintain position through absolute strength. They persist through organization, movement, rhythm, and group discipline. No emotional factor or preference influences the outcome. Instinct, efficiency, and adaptability alone determine which species continues to hold position within the harsh savanna predation chain. Solitary behavior is not always selected. Male cheetahs often form alliances. Two or three individuals, usually litter mates, move together. Cooperation allows targeting larger prey and protecting captured food from intrusion. A blue wildebeest appears. Body mass reaches approximately 550 pounds, which is 5 times heavier than a cheetah. The body is covered with thick skin. Horns are curved and sharp. Hooves are solid. For a single cheetah approach, risk approaches self-destruction. The alliance converts risk into strategy. Cheetahs assign positions approach from multiple directions and control movement trajectory. Speed, endurance, and coordination create effective encirclement. Each step and movement aims to reduce counterattack opportunity. The hunt ends in success. The prey is taken down cleanly. Cheetahs feed slowly without urgency. There is no need to drag the carcass upward or fear loss to competitors. Cooperation removes pressure and risk. Each alliance member maintains position, maximizing efficiency and securing success. This hunting form demonstrates coordination and tactical capacity in nature. Collective strength surpasses solitary ability. Speed, endurance, and organization generate decisive advantage. The alliance not only captures larger prey, but preserves energy and reward, confirming survival efficiency in the wild. In the Serengeti, spotted hyenas are true predators. A large domed skull contains extremely thick jaw muscles. Bite force reaches 1,100 pounds per square inch, exceeding lions and leopards. conical premolars are designed to fracture the physical structure of prey. Spotted hyenas are the only species in Africa capable of crushing the long bones of buffalo or giraffes. The digestive system contains highly concentrated hydrochloric acid that breaks down bone, teeth and horn. After feeding, no remains are left behind. Long-term research shows that 70 to 95% of hyena food intake comes from active hunting rather than scavenging. The heart accounts for nearly 1% of body weight, providing endurance for speeds of about 37 miles per hour across distances of 3 to 6 miles. Prey does not die from wounds. It dies from exhaustion after continuous pursuit until resistance is no longer possible. From approach to capture and food processing, every detail shows a body evolved for long duration and efficient hunting. The Serengeti records comprehensive hunting capability, including strength, speed, and specialized digestion, combining to place hyenas at the top of the food chain. Spotted hyena society operates under an absolute matriarchal system. Females are larger than males and display higher aggression resulting from androgen exposure before birth. Even the lowest-ranking female holds dominance over the highest-ranking male. The control system relies on complex political alliances. The frontal cortex is highly developed, supporting individual recognition, vocal memory, and tracking of hostile relationships across generations. The characteristic laughing sound does not express emotion. It functions as an information signal encoding age, status, and physiological condition. Hyena clans coordinate and interact continuously to maintain order. Each individual clearly understands position, role, and authority. Internal conflicts are resolved through signaling, body pressure, and temporary alliances. Confrontations with lions occur regularly and determine ecological balance in the Serengeti. Hyenas maintain clan strength, coordinate hunting, and defend territory. Every behavior, from rally calls to hunting tactics, reflects social structure and advanced memory capacity. The combination of matriarchal organization, individual memory, and acoustic communication forms a structured society. This system maintains order, controls power, and optimizes survival capability in a challenging wild environment. If the Serengeti functions as a zone of conflict, the Grumeti and Mara rivers serve as lethal corridors. Turbid water conceals survivors from the age of dinosaurs, the Nile crocodiles. When the dry season lowers water levels, crocodiles withdraw. Heart rate drops to a minimum. In a resting state, they can hold breath for up to 8 hours. While waiting for the largest annual event, the Great Migration. When millions of wildebeest and zebras are forced across the river, crocodiles strike. Bite force reaches up to 5,000 pounds per square inch, 5 times greater than hyenas and 8 times greater than lions. Teeth are not used for chewing, but for holding. The remainder relies on physical mechanics. Crocodiles clamp prey and rotate along the body axis, tearing flesh into sections. Afterward, the highly acidic stomach completes the process. Acid strength is sufficient to dissolve flesh, bone, horn, hooves, and even metal. Crocodiles combine weighting, reaction speed, and physical mechanics to control prey. Each bite and each rotation maximizes hunting efficiency. This process requires limited energy while ensuring success. River corridors become zones of lethal pursuit. The female crocodile fasts for 3 months to guard the nest. Eggs are protected against monitor lizards, baboons, and potential intruders. The body remains motionless, while eyes monitor all movement around the nest. Any intruder faces deterrence through crocodile strength. When eggs hatch, hunting behavior temporarily withdraws. Powerful jaws become flexible enough to gently hold hatchlings. The female releases young into water, ensuring safety during early life stages. Ferocity and care occur simultaneously. Crocodiles function as apex predators, while also serving as effective protectors of offspring. Each action reflects survival optimization, including nest, defense, strength, maintenance, and protection of the next generation. In the wild, survival and care are not mutually exclusive. Nile crocodiles clearly demonstrate this through every movement, from egg guarding to releasing hatchlings into safe water. At Retina Lake in Savanna, from a distance only scattered grey rock-like forms are visible. At closer range, strong odour and low rumbling sounds reveal the reality. Hundreds of hippopotamuses crowd together in mud. They remain almost motionless at the water surface as dense bone structure prevents buoyancy. Hippopotamuses move along the river bottom as if operating in a low-gravity environment. The skin is extremely sensitive to ultraviolet radiation. They secrete a red, oily substance that functions as sunscreen and antibacterial protection, keeping skin from injury and infection. This mechanism is a refined survival adaptation that maintains health under harsh conditions. The primary danger is located in the mouth. The jaws open to 150 degrees and the lower canines extend up to 19.7 inches. This species represents the large mammal with the highest fatal risk to humans in Africa. During daylight, hippopotamuses gather in groups. At night, individuals leave the water and travel alone to graze. An adult can consume up to 88 pounds of grass across a distance of 6.2 miles. Waste released into water becomes a nutrient source for aquatic ecosystems, sustaining natural cycles. Hippopotamuses represent a combination of muscular power, skin protection mechanisms, and ecological behavior. From crowding in mud to delivering extreme bite force from underwater movement to terrestrial grazing, every detail is optimized for survival. Retina Lake becomes a living stage for one of the largest mammals, where strength, physiology, and behavior combine to maintain position within a harsh ecosystem. The dry season applies widespread pressure across the savanna. Water levels gradually decline. Grasslands lose moisture. Easily accessible food sources are rapidly depleted. Species are forced to adjust feeding strategies and activity rhythms to maintain survival. Warthogs adapt by exploiting less competitive food sources. Hard roots are dug from dry soil layers. Old tubers and withered grass replace fresh biomass. These resources provide limited energy, but are sufficient to sustain basic activity over extended periods. Tolerance to water scarcity allows warthogs to extend travel time between drinking points. They reduce movement during the hottest hours of the day. Foraging is concentrated in early morning and late afternoon when temperatures are lower. Biological rhythms are adjusted to limit water loss and energy expenditure. However, tolerance is not unlimited. As drought persists, stored reserves decline noticeably. Reaction speed decreases. Travel distance is reduced. Pressure to locate water increases with each passing day. At midday, the savanna becomes nearly motionless. Sunlight blankets the ground and forces most movement to a minimum. Most predators retreat into shade and wait for temperatures to drop. However, one exception remains active during this time window. Cheetahs do not depend on cooler periods. Their vision is optimized for open terrain and intense light. Two dark tear lines beneath the eyes reduce sunlight reflection from dry ground, preserving image clarity at long distances. Under conditions that limit visibility for many species, cheetahs retain the ability to detect targets. Near a shallow water pool, signs of dispersion begin to appear. A juvenile warthog separates from the group after drinking. Distance from adults increases steadily. The return path lacks cover. The ground is open, with no complex terrain to conceal movement. The lion body is optimized for short, explosive bursts. Large muscle mass and powerful hind legs generate strong propulsion. Speed can reach very high levels, but only lasts for the first few seconds. Breathing rate then increases rapidly and heat accumulates while performance declines clearly. Hunting for this species is not a long-distance pursuit. Strategy, therefore, focuses on the initial moment. The approach must reach sufficient proximity. Force is committed in a short charge. If prey escapes the decisive distance, the ability to continue pursuit nearly disappears. Prolonged effort only consumes energy and increases the risk of exhaustion. Many hunts end immediately when the first strike fails. During the dry season, survival pressure increases. Food becomes scarce. High temperatures reduce physical tolerance. Lions are forced to adjust target selection. Prey with unpredictable escape paths or high endurance becomes a risk. Priority shifts to species with familiar movement patterns, limited reflexes, and short-range counterattack ability. Warthogs fall into this group. Body size is moderate. Movement often follows habitual routes. Escape distance is short. In many cases, this choice fits a rapid burst strategy. However, this calculation works only when environmental conditions are supportive. Today, heat becomes the major barrier. Intense sunlight accelerates dehydration and overheating faster than expected. After only a few acceleration cycles, breathing exceeds controllable limits. Muscles become heavy. Distance does not close fast enough. The prey exits the pressure zone. The decisive moment passes. The hunt no longer has a basis to continue. Stopping is not a choice, but a biological requirement. Additional expenditure would reduce hunting capacity in the following days. When the lion withdraws, the space returns to a neutral state. There is no carcass. There is no clear sign of conclusion. Only footprints remain on hot ground, along with extended heavy breathing. Failure is not rare. It reflects structural limits of the body under specific conditions. Explosive power provides major advantage only when timing, temperature, and distance align. When one factor shifts, the outcome changes immediately. On the savanna, no organism holds absolute dominance. Predators fail when speed, position, or distance are insufficient. The presence of warthogs, lions, and other species creates a continuous reaction chain. When herds move, soil compresses, dust rises, and grass structure changes. All behavior is measured by energy expenditure, movement distance, and immediate survival capacity. This interaction chain operates continuously without pause. No species remains superior over long periods. Each individual contributes to maintaining ecosystem balance. The savanna persists through cycles of migration, hunting, response, and rest. Rhythms of movement, feeding, separation, and access to water ensure survival in harsh conditions. Serengeti, where grass scorches under sunlight, allows no margin. All organisms are exposed, with no place to conceal. The cheetah moves cautiously in heat at 89.6 degrees Fahrenheit. Hunger prevents stopping. Prey appears. A solitary warthog is present. The cheetah identifies position from distance, with vision unaffected by heat shimmer. Distance remains at 164 feet. The slender body stays hidden within tall grass, nearly invisible. Soft paw pads and toe walking allow silent approach. Near termite mounds and dense brush, the surroundings remain still. The warthog lies motionless. Across its body, an entire group of mongooses moves while searching through skin folds. This is a purely biological process. Warthogs live in mud and burrows, which accumulate ticks, fleas, and parasites. Without removal, health condition declines rapidly. Mongooses search for food while performing a sanitation role. They inspect skin folds, ears, eyes, and small crevices. Each parasite removed, and each movement is precise and efficient. The warthog maintains position and remains completely still. There is no movement and no resistance. All activity focuses on completing cleaning. When the process ends, the warthog stands and resumes life in mud and burrows. This moment records direct interaction between two species. It represents a refined ecological mechanism where parasites are controlled and protein is exchanged. Every movement and action by the mongooses serves a defined purpose. When the process ends, the environment returns to a quiet state while biological effects remain present on the warthog body. After the hunt, the cheetah enters a state of exhaustion. Breathing becomes rapid, body temperature remains elevated. Muscles have not yet recovered. At this moment, another threat enters open space. Baboons appear in groups. They do not hide. They do not approach covertly. The troop advances openly and forms a closing front. Distance narrows meter by meter. Tusks exceeding 2 inches in length are clearly visible. Attack posture requires no concealment. Large males hold central positions. Other individuals spread outward, blocking all retreat paths. Ground vibration increases through repeated forceful impacts. Vocalizations project continuously. Visual focus remains concentrated without dispersion. There is no physical contact. Pressure is generated through sound, movement, and numbers. The cheetah does not respond. Energy levels are insufficient for acceleration. Defensive capability is nearly absent. There are no claws suited for close combat. Bite force is insufficient. No supporting individuals are present. All options remain restricted. Cheetah body structure is optimized for straight-line, high-speed movement. The skeleton is light. The spine is flexible. Semi-retractile claws function primarily for ground traction during acceleration. In direct confrontation, these features provide no advantage. Injury to a forelimb or hind limb can end hunting ability. For a species entirely dependent on speed, this outcome becomes irreversible. Serengeti does not belong solely to lions or cheetah sprint paths. It functions as a tightly structured and severe hierarchical system. Every ecological niche is occupied by specialized predators. Apex predators regulate populations and maintain ecosystem balance across millions of years. Spotted hyenas, leopards, African wild dogs, cheetahs and lions each perform a distinct and irreplaceable role. Serengeti is not shaped only by predators. Wildebeest herds form a continuous energy flow through the ecosystem. With numbers reaching 1.5 million individuals, they create the largest living mass on the savanna. Movement, migration, and survival of each individual sustain the overall rhythm of life. Every predator and every prey species functions as a critical link. Role distribution, population scale, and hunting strategies create a stable ecological network that persists across millions of years, keeping Serengeti active and under constant tension.
After the chases, defenses, and territorial fights, each species returns to its most basic need. Keep living. A predator must recover its strength. Prey must keep the herd from breaking apart. Mothers continue leading their young through ground marked by tracks and the scent of danger. Some individuals gain a meal, others lose their final chance. But the result of one encounter never belongs only to the animals involved. What remains will feed other life, return nutrients to the ground, and begin another cycle. In the wild, no position is held forever. Every advantage has a limit. Every choice leaves a consequence. When a new day begins, life moves again, carrying old losses and another chance to continue.